Hello guys. So looking at this question, we actually need to provide three answers. Find what meant to find the concentration of the oxygen in the air, and then calculate the diffusion rates. Then also estimate the average time for molecule to diffuse in. So we'll be using about three formulas. So C is equal to, which will help us calculate the concentration of the oxygen. C is equals to P. Since we'll be treating oxygen in this case and as ideal gas, C concentration is equals to pressure over the universal constant of gas multiplied by temperature, which is our equation one. Then equation two will be tackling the rates. We'll be calculating the diffusion rate, assuming the diffusion constant is 1 times 10 raised to power negative 5 meters squared. So in order to calculate the diffusion rate, we would have to use the expression for the diffusion rate formula, which is J is equals to D A, then change in concentration in the trachea compared with that of the atmosphere divided by X. And then we have to find or estimate the average time for a molecule to diffuse into the trachea. So, um, so for the third question, we would be utilizing the expression for the average time of diffusion to occur. So that would be T is equals to C concentration average multiplied by sorry, A, then the changing area divided by diffusion rate. Or just name that as J, diffusion rate. Yeah, so yeah, this is the formula we'll be using to calculate the average time for diffusion to occur. Yep. So starting from the first equation in calculating the concentration of the oxygen in air. So in order to calculate the pressure that would be occurring at each length of the trachea, we'd have to calculate the pressure occurring at every part or every area of the trachea. So we'll be taking into consideration the area of the trachea, which is given as 21 millimeters. So converted it to meters, we'll have 0.21 multiplied by the pressure at a specific area, so which will give us the total pressure or the total pressure affecting the area of the trachea. So this is 0.2 multiplied by 1.013 times 10 raised to power 5 divided by the universal gas constant, excuse me. So that would be 8.315 multiplied by temperature. And in converting temperature, in this case, it is 20 degrees Celsius. So we have to convert this to Kelvin. So that would be 20 plus 273. 20 plus 273 Kelvin. Yep. So we have 20 plus 273 Kelvin. Yep. So punching all this into a calculator, we should have the concentration as, hold on, let me see if I could, no. Well, I'll just hold on, guys, as I punch this into a calculator. 0.21 multiplied by 10 times 10 points, 1.013 times 10 to the power 5. Oh, okay, yeah. This is 8.7, 8.7 moles per meter cube. Yeah, so this is answer to the question A. And now, since we've been given the value of the concentration, we can then go on to find the expression for the change of concentration, which is this in order to calculate the diffusion rate. Since we've not been given the expression for change of concentration, we can go on to find it, which and the formula for calculating the change in concentration is change is equals to 1 1 over 1 divided by 2 C. Yeah. So from the first question, we found out what our C is, which is given as 8.7 moles per meter cube. So we'll just substitute that value for C. So we'll have 1.2 1 divided by 2 multiplied by 8.7. So there you have it. And now we can input the value or the calculation of this into our equation right here. So J is equals to, and we've been given the diffusion constant. So the diffusion constant, guys, as 1 times 10 to the power negative 5 meters square. So using the diffusion constant given in the question, the change in concentration, we can find the diffusion rate. So 1 times 10 to the power negative 5 times 10 to the power negative 5 multiplied by 2, which is the cross-sectional area of the trachea, 2 times 10 to the power 9 times 10 to the power negative 9, sorry, negative 9, yep, multiplied by 1.2, which is the value of the change in concentration, 1.2, sorry, 1 over 2 rather, sorry guys, 1 divided by 2 multiplied by 8.7 divided by 2 times 10 raised to power negative 3. 2 times 10 raised to power negative 3. 2 times 10 raised to power negative 3. Yep. So also punching this into a calculator. 1 times 10 raised to power negative 5 multiplied by 2 times 10 raised to power negative 9 multiplied by 1.2 divided by multiply 1.1 divided by 2 multiplied by 8.7 divided by 2 times 10 raised by negative 3. J, which is the diffusion rate, is equals to 4 times 10 raised to power 11. 4 times 10 raised to power 11. 10 raised to power negative 11 rather. So 4 times 10 raised to power negative 11 moles per second. So this is the diffusion rate. This is the diffusion rate. And now for the final question, which is estimated average time for a molecule to diffuse in to the trachea. Horizon. So we have using the third formula, which is T is equals to concentration average multiplied by cross-sectional area multiplied by the change multiplied by x divided by the diffusion rate. So now we've found the diffusion rate, which is giving us 4 times 10 raised by negative 4 times 10 raised by negative 11 moles per second. And we've also been able to calculate the average concentration change and also our concentration. So now it's time for us to calculate the amount of time or the average time for a molecule to diffusing using the T is equal to C av multiplied by A multiplied by X divided by J. But we haven't been given C average. We haven't been given C average, so we would have to substitute the value for the average equation for the average concentration. So C average C average would be 3 over 4 multiplied by 8.7 0 4 multiplied by 8.7. So this would give us the average concentration per time. So using the concentration found here as 8.7 times 8.7 moles per meter cube, we can be able to find the average concentration in order to calculate the average time for a molecule to diffusing. So finding our answer of 3.43 divided by 4 multiplied by 8.7, C average, which is also average concentration, C average should be equal to 6.5 6.53 moles per meter cube. So this has given us the average concentration, and then we can go on to find the amount of time for a molecule to diffusing using our third equation. So using the third equation, we have 6.53 multiplied by, let's go back to see the equation, on the cross-sectional area, which has been given in the question as 2 times 10 to the power negative 9, 2 times 10 to the power negative 9 multiplied by 2 times 10 to the power negative 3 divided by 4 times 10 raised to the power 11. So all those values are been gotten from the equations we have solved: the diffusion rate, the concentration, diffusion rate, the concentration, the average concentration, and also from the question we've been given some of the values. So basically we have all we need, and we can go on to find the go on to find excuse me the we can go to estimate the average time for a molecule to diffusing, and by punching all this into our calculator we should have t t is equals to this, then therefore t is equals to hold on guys, this is okay, as that gives me 0.57, but rounding up we have 0.6 seconds. So the estimate of the average time is 0.6 seconds. Yep, 0.6 seconds. So we have our third answer as 0.6 seconds, our second answer as 4 times 10 raised by negative 11 mole per second, and our first answer is 8.7 moles per meter cube. Thank you.